morning.
Morning.
Hi. So day 2, yesterday, day 1 in Unit 11, we added and subtracted polynomials. Recall that when we did those additions, we didn't change the exponents. Today, we'll be multiplying these terms together, multiplying things with the same variables. And when you multiply same variables, you add exponents. All right? Okay. For a lot of you, this should feel like review and very easy, and you may already have a method that works really well for you and will always generate correct answers. Awesome. So if that's you, then just do your thing. Some of you may be sitting here looking at this going, you know, I saw what they did, but I wasn't ever really sure why they were doing the thing that they were doing. And yeah, or how they were getting the numbers that they were getting. Okay, so for those of you that are sitting in that position, I wasn't ever really sure how they were getting the numbers they were getting. This is for you. Everyone else, just chill with us, relax, and let's do this. It's distribution. Okay, so we're going to multiply the very first thing
with all of them
by all of the stuff inside the parentheses, and when we're done, there won't be any more parentheses.
Question, just the
Answer.
-2 or the negative 2x?
All of it. So here's what we're going to do. I'm going to grab that term and multiply it to this term. I'm not going to do the multiplication yet. I'm just going to write I have to do the multiplication because I want to show you some behind the scenes stuff that happens that makes this really easy. Okay? So I'm going to multiply those two things together. Now I'm going to multiply that times the next term. So multiply this entire term times the entire term. I'm going to do the same thing to the next term. And I'm going to do the same thing to the last term. Okay? Now that I've written down I'm supposed to do the multiplication, and I've grouped everything by color, those are the things that are associated together, now I'm going to show you how the multiplication actually happens. Take the coefficients, those are the big numbers out in front, and multiply them. -2 times 10 is? What's the variable? X. So I'm going to write the variable. Now I'm going to take the exponents, and I'm going to add them. 4 plus 3 is? That's it. We're done. That's how the multiplication happens. Do you want to see it again? Mm-hmm. All right. Take the coefficients, the big numbers in front, multiply them. -2 times -9. Positive 18. And thank you for including that, whether it's positive or negative, because that's what determines whether we're going to write an add or a subtract. What's the variable? X. And then add the exponents, you get 6. Good. All right, do it again. Multiply the coefficients. Positive 14. What is the variable? What's the exponent?
4.
All right, I love that we had a difference of opinion. Someone said that our new exponent is 4. Someone else said our exponent is 5.
It's positive 4.
Here's the reason. What's the exponent here?
4.
Easy because it's written. What's the exponent here?
1.
1 because it's not written, but the variable is still present. So 4 plus 1 is
5.
plus, not multiply, plus. 4 plus 1. Okay. All right. Multiply the coefficients. -2 times 4. What's the variable?
X.
And what's the exponent?
4.
5.
It's
Wait,
4.
4.
The 4 doesn't have the x.
4 because this doesn't have a variable.
So when it has an X, then that's when it has
Then it has a 1. If there's no variable, it's not there, so we're not going to add anything. Okay, in reality, if I wanted to put a variable, I could, but then I would have to put an exponent of 0. 4 plus 0 is 4. We don't have to put that extra variable, okay? You don't have to do that. That's it.
And we don't solve, we just do it like that.
Yeah, because there's no equal sign. There's no equal sign, so we don't need to start moving things over the equal sign. I wasn't given a value for x, So I don't need to simplify any further. I don't have to evaluate. That's it. We're done. Easy enough? All right, now that you've seen the why things happen, can I just write the shortcut, or do I still have people that want to see this out first? Just the shortcut? Okay. Do you feel better about the shortcut now that you've seen the reason behind it?
Yes.
Yes? All right, good. Let's look at this one. When we came in and before I clicked on the recording, I heard a few of you say, oh, we did FOIL on this.
First outer, inner last.
Yeah, that's not the name of this process. That's a trick to help you remember what order to do stuff in. The actual name of this process, wait for it, binomial distribution. Okay, binomial means I got two terms. Look, I got two terms. I got two terms. And distribution is that stuff, distributing. But I'm distributing with things that have two terms. So binomial distribution. That's the proper term. Okay, let's do that whole FOIL thing. Going to multiply these two together. I'm going to do the shortcut since you said it was okay to now. Stay with me, stay with me. Do. I know this is really easy for some of you. That's okay. All right. Questions on how I got the thing that I got? Okay, good. The colors show up easier now. Am I done? Why not? There's like terms. There are things that have the same variable, and those variables have the same exponent, which means I got to combine them. All right, it's going to combine these two, which are my like terms. I'm not going to change these other two. -6 plus 10.
Plus 4.
-4 plus 4. Which one? Which one is it? Is it a -4 or is it a +4? It's a +4 because 10 is a larger number, and so we're going to grab that one sign.
So we just go by the large number?
Yes. Cool?
Is that one is next squared?
On this one, it is not because we're adding the terms. When you add the terms, you leave the exponent alone. When you multiply the terms, you add the exponents. Let's look at number 6. What do you think about this one? It's the same thing. We just have one more term that we've got to keep track of. Do you want to see how this one works? Yes? Okay, I heard a few no's. If you're one of the no people, that's fine. You just do it. If you're one of the yes people, this is for you. Whoops, as I smack my camera. Multiply these two together. And these two together. And those two together. And these two together. And these together. And those together. Going to take a moment to look for like terms. And I'm going to rewrite it while combining like terms. No more like terms, nothing else I can multiply together. I'm done. I don't know whose it is, but it's still there. Or is that me? It's not me. Okay, it's gone now, whatever it was. All right, let's look at 8. What does it mean to square something?
Times it by itself.
Yeah, how many times? Twice. 2 times. So I'm going to multiply this thing to itself 2 times. So this entire thing times itself
Twice.
twice. It's this. I have seen in this class, in a bunch of others over the years, I have seen this. Please no. No. Do not distribute the power if you have anything with additions or subtractions in it. See how we have a plus sign in there? Don't distribute the power.
So if it's multiplying, we can distribute it?
Yes. If it's all multiplications in there, do it. Distribute to your heart's content. If it's addition or subtraction, don't distribute. You have to write it this way. And then you have to distribute here. Okay? Okay. Now that we've got number 8 set up like this, it looks exactly like number 4. So I don't feel that I need to do it again. Is that okay? Okay. Turn the page. Which is an awesome song, by the way. Look at just the top 4. I have a feeling that some of these make you feel like you've got hives. Which one?
9.
9 and 12. Okay, let's look at number 9 briefly. This works exactly like the binomial distribution. You just have a lot more stuff to keep track of. So that's why I have all of my colored pens out today. So that way I can try to keep track of this stuff. So those 2. And then this one. And then this one. Sorry if that green is a little too hyper bright. I need the extra color today. Then this one. And this one. And this one. Oh God, I'm running out of room. Ah! Okay, now this one. I should have written smaller. Sorry, number 10, I'm going to run into your space here. I got it all. Exactly the same process as before. There's just a lot to keep track of. And just like before, take a moment to look for your like terms. Oh, right here. I made an error. Did you see it? 7x times x squared should have been 7x cubed. So here and here. So should be that. Okay. Okay. Let's see. 6, 2, that's 8. 8 from 21 is, well, it's just, their signs are different, so it's going to feel like subtraction. 13, I think. Okay, and it's a positive. Oh my God. That was a lot. And it's okay, some of them are gonna be that. Just let it take the space. Whatever you need to do to help you keep track of your like terms, do that, and you'll be just fine. Remember, when you're adding like terms, leave the exponents alone. When you're multiplying, add the exponents. The next one was number 12. So with number 12, I think the easiest trick on something like this, when you've got 3 things you're multiplying, is ignore one of the groups, multiply the other 2 groups. As soon as you get that down as small as you can, then you multiply the 3rd group into it. So that's what I'm going to do. I'm going to ignore the last group, and I'm going to handle just the first 2 for now. And this should feel just like our binomial distribution using that FOIL method.
So you combine like terms so you finish?
I'm going to go ahead and combine like terms on this one now just to make this smaller so I have less to distribute. And then I'm going to distribute again. Okay. Do you need to see any further on this, or is that enough for you to know what we're doing next? That's enough, or keep going? That's enough for her? That's enough? That's enough. All right, I checked with all corners of my room. Cool, let's look down at number 15. What should I write? 2v minus 1, that entire thing 3 times. Yes. And then now it's going to look exactly like number 12 that we just talked about. Is there a shortcut? Yes, I'm so glad that you asked. There is. Show us. Not yet. I'm so mean. Hashtag spoiler alert. You can Google Pascal's triangle. That's totally the shortcut. As everyone, great. Everyone don't pull out your phones. Pascal's triangle. That's the shortcut to this. I'd like to see you do out the full distribution. But Pascal's triangle will, I'm still trying to decipher that shortcut. On the 2 and 3 exponent, it doesn't really feel like a shortcut, but once you hit like power 10, it's totally a shortcut. All right, let's look at 16. There's a mistake. Going from the left side of the equal sign to the right side of the equal sign, there's an error. What is it? The 15 should be a positive, because when I distribute this to this, a negative times a negative is a positive. Is that the only error? No, it's not the only error?
The positive on the 21 should be a negative.
The positive on the 21 should be a negative because I have a negative times a positive. Describe the errors. You're just going to write what we just said in a full sentence. The 15 should be a positive because blah, blah, blah. 21 should be a negative because blah, blah, blah. And then you're going to write out what it actually should be. Glance at 15. We have another error. I'm sorry, 14. Looking at number 14, there's another error. The exponents are incorrect. What did they do here to generate the exponents? Yeah, they multiplied the exponents instead of adding them. All right, that's it. Good job, guys.